Hi, this is a little video from Algebra 2 Semester 2 lesson using matrices to solve linear systems. It's page 598, number 12. Okay, so the directions say, solve the system by writing and solving a matrix equation. So the first thing we're going to do is take these two equations and put them in a matrix equation. And that's pretty basic. So we're going to have basically three matrices, and it'll look like this. The first one is going to be the coefficients, and it will be 2, 2, negative 3, negative 1, then x, and then y, and then 18, and negative 19. So let's give these matrices these names. We'll say this first one is, we'll call it A, capital A. The second one, their variables, we'll call X. Let's make it a big X, a capital X. And then this third one, let's call it B. So this is matrix B, matrix X, and matrix A. Before we go any further though, let's pause and review how to solve a linear equation for X, okay? So suppose we have an equation 3x equals 6, and we've got to solve for it, right? What we need to do is isolate the x, and how do we do that? We multiply by 1/3. We multiply both sides, right? By 3x equals 1/3 by 6, all right? And then we get x equals 2. But if we take a look at this, what is this 1/3? Well, this 1/3 is called the multiplicative inverse of 3. So now let's take this information that we have here and apply it to matrices. Now let's take this matrix here and the names of the matrices and set them up as an equation, right? Matrix A times matrix X equals matrix B. And we know we've got to isolate or kind of solve for the variable. Well, how do you do that? We need to multiply by the multiplicative inverse of A. And what does that look like? A to the negative 1 times A times X equals A to the negative 1 times B. Because anything to the negative 1, that's an indication that means it's the multiplicative, it's the inverse, right? And when we solve that, right, the multiplicative inverse of A times itself is just going to give you 1. So we'll be left over with X equals the multiplicative inverse, the inverse of A times B. So that's what we're shooting for. So what we need to do now is, well, we know what X is, we know what B is, but we don't know what the multiplicative inverse of A is. So that's what we've got to figure out. Once we figure that out, we're kind of home free. So let's take a look at how to find the inverse of a 2x2 matrix. So if it exists, the inverse of matrix A, right, A, B, C, D, is the inverse of it is 1 over the determinant of A times D, negative B, negative C, and A. So look, we know what A, B, C, and D, we know what they are. So all we need to do to get this other matrix over here is to rearrange them and say, well, here's D will go here, and then this becomes negative B, this position becomes negative C, and this position just becomes A. But before we do that, well, let's just write down our what A is. We know, just for reference, we know what A is. Matrix A is equal to, right? So we'll go boom, 2, 2, 3, negative 1, okay? Now we need to find the inverse of that. And the first thing we need to do is find the determinant. So let's do that. Let's find the determinant of A, right? And that's just going to be equal to 2, because we've done this in previous lessons, so you should remember how to do the determinant. If you don't know how to do that, then go back and learn how to learn how to do that, or repractice that. And you crunch these numbers, and what do we get? Negative 2 minus negative 6, and we get negative 2 plus 6, and we get equals 4. So the determinant of A is 4, and so we're going to say, let's go the inverse of A is equal to 1 over 4. And what's D? D is negative 1. What's negative B? Negative B is just negative 2. What is negative C? C is 3, so the negative of that, or the opposite, is negative 3. And then just A goes over here, and A is 2. Okay? So then you just multiply that all out. And we're going to say the inverse of A is equal to negative 1/4, negative 3/4, negative 1/2, and 1/2. Voila, look at that. It's that easy. So now that is the inverse of A. Let's go back. So we've identified that. Let's go back here. And so we have to say x is equal to the inverse of A times B. And let's see, I can erase some stuff here. We'll erase some stuff here. Boom. Free up some space. Okay. And so what that's going to be, that's going to look like, boom, let me see, boom. I'll go back to here. To do this, we're going to have the matrix X, Y is equal to, right, we came up with our inverse, and that's negative 1/4 times 3/4, negative 1/2, and 1/2, right, because that's the inverse, times B, which is 18, and negative 19, right? And when you crunch those numbers, when you multiply these two matrices together, and you've supposedly done a fair amount of that already, you will get the vector 5, 4. So that means x equals 5 and y equals 4, or the ordered pair 5, 4. So this represents the solution set to this system of equations. And of course you can check that by plugging 5 into x, 4 into y, and making sure that that works, right? And look, 5 times 2 is 10, plus 2 times 4 is 8, is equal to 18. That checks. 5 times negative 3 is negative 15, minus 4 is equal to negative 19. Voila, that checks. Okay, I hope you found this helpful.